Okay, welcome to our weather discussion. I haven't looked at this, so I'd rather just jump right to the weather discussion. You guys have been looking at this unless there's other comments.
Not really.
Okay, so we'll start with our little satellite movie over the continental U.S. when Pete's done corresponding with all of our remote visits.
Getting things set up. You want the...
No. Yeah, that's fine. Okay, so here's our satellite movie over the last 6 hours, is it? Let's see.
It should be 6 hours.
Yeah, so it's about 4. Okay, it's about a 4-hour loop over the continental United States and mostly the Atlantic. And so you can see a couple of interesting things. One of the things that was interesting about the weather this week was, of course, this weird storm that bounced back and forth in the forecast for the week preceding its occurrence, Tuesday and Wednesday and Thursday. There were times when we were forecast to get 20 inches of snow in a day. There were times when we were forecasted to get 6 or 8. That hung on for quite a long time. And then one of the things the Weather Service, I don't know if they received any criticism, but if they did, they deserve it. They on Monday, no, it must have been Tuesday afternoon at noontime, after the 12Z runs were in, and I looked at all of them on Pittsburgh from every single guidance that we have available at that time. There was no chance of Madison getting any snow at all. And that was all in the forecast. And Milwaukee, too, was down to about 0. And yet, the legacy of the prior week's forecast still had in it a forecast of 2 to 4 inches of snow. That is not right. I mean, you can't, on the one hand, say that the guidance has gotten to such a state that we believe it now. You're testifying to that in your legacy forecast. And then not believe, when everything finally gets resolved over the continent, that it's not good anymore. And I'm going to rely on 2 to 5 inches as the legacy forecast. Terrible mistake. I don't think they got much criticism for it.
I think people call that momentum bias for the forecast, because it will happen a lot with severe weather events as well, where you'll get something that looks really good, they latch onto this high-end scenario, and then as it changes, they still get fixated on high-end scenario, and the forecast has momentum with it.
And what's the root of that? The root, I think, is cultural, in that I think, and I'm speaking without knowing for sure, but I've heard from friends of mine in the Weather Service, there is a penalty to be absorbed if you depart from a legacy forecast. And it turns out to not be a smart move. And I think that is really a bad idea.
What's the penalty?
The penalty is I don't know what it is exactly, but you probably get some criticism from higher ups and various things like that.
It might be their actual forecast score, because they have internal scores for the forecasts that are issued, on top of also maybe a penalty with, I know they get penalized if their CWA borders don't match up with the other offices and the DFE grid, so it's probably a combination of those two.
But it seems to me that if you have a forecast that you're issuing going forward, you know what you did in the past, and there's no reason to hang on to it if you have a better forecast.
Right, exactly.
Well,
It's
that's
a
supposed to be WPC, so WPC is putting out high QPF forecasts, they can't necessarily go straight against them either. So consistency across all the agency probably plays into it.
So it's sort of a pack mentality. But
I think where we criticize them is that after they even went for like less than an inch of snow for all southern Wisconsin, when Racine and Kenosha ended up with a couple of inches. So they even underestimated when there was no need.
I was just struck by the noontime forecast. Official Weather Service forecast saying still 2 to 5 inches of snow. It was completely out of bounds. There was no way that was going to happen anymore.
Sorry, I was watching remotely, but in the forecast, it seemed like there was sometime, I don't remember when it started, there was a clear trend in many of the models to begin to move. If you remember Weather Watch last week, we were talking about this potential period of extended light to moderate snow for 36 to 48 hours. Right after that forecast, we were kind of right in the bullseye for 10 to 20 inches roughly. I don't remember the exact numbers. But at some time late in the weekend, last weekend, it began to shift slowly southward. Some models like UK Met had us in the clear for no snow. I think by the 12Z Sunday or 0Z Monday run, we were totally out of snow, whereas GFS and East WF continued having us in this band of snowfall. But it was slowly, almost reliably shifting further and further southward.
And
these forecasts,
and the overall picture of, if you just paste the snow band in a different place, the 24-hour accumulated snow, it got thinner and thinner and thinner no matter where it was moving. So there's both things working against it. So
an interesting case to look at dynamically, and I'm glad maybe a lot of people share this. I'm not paid to make those forecast decisions, but this seemed to be one in which you could have moved early on saying the chances of significant snowfall have decreased
I
significantly.
think you could have, and especially when you think about the broad scientific elements at play here, I think anyway. The cutoff that we saw last Friday was, they're always difficult to figure out how exactly they're gonna get themselves rejoined with the westerlies. And then we also had an upper disturbance, mostly upper front type disturbance that was not well resolved off the west coast on Friday. Those are two big question marks. Perfectly reasonable to have forecasts bounce up and down. And I think I don't have any problem with that. Once those things both got resolved in the network, and you still went back to your old forecast, which was made when things were not so well resolved, that I cannot understand except as a function of a culture that's a little bit too suffocating.
Giving benefit of the doubt to the forecasters, I think it's a requirements issue.
Yeah, and
And also
Caitlin
in
kind of
internal
said,
office politics of if the lead is the one that made the previous forecast, there could be some issues with not taking that too much.
yeah, I completely understand it. That's why I say that I think it's a cultural error that, is not an attractive aspect of the way these kinds of things get handled in the end. Because we've got really sophisticated, exceptional tools at our disposal, but we're smothering them sometimes because of a series of circumstances that have led to them bouncing up and down in the forecast, and that's because parts of the forecast were unresolved.
Right, now, did the headlines in the forecast that were communicated to the public, right, you can keep maybe you're required to keep the forecast a certain way, but in the other language, their weather stories, were they highlighting in a vigorous way, forceful way that this looks like this forecast is coming apart, and we're gonna.
I can't say, I don't know.
Right,
I don't pay enough attention to the media, because I'm looking at it myself all the time.
I mean, just the Weather Service, they have their weather stories panel that they have.
Yeah, but you have to go to the website to find
Right,
it, so it's not, I don't do that very often, so I don't know the answer to that. It's a good question. And I agree with you on your other comment that I'm glad I'm not a professional forecaster. I think especially in instances like this is really a tough forecast as it turns out. And I don't lay any blame on anybody's shoulders for getting it wrong 3 days in advance. But when it's a day in advance and you've got great, state-of-the-art guidance, that is a little bit more of a problem. So here's what's the result of that. That's what got me off on that story. Here's the result of that storm. It got a little bit better organized, but it's very expansive by the time it moved east. And so this is all part of the same broad circulation. And I think it's centered maybe around just north of Maine or off the Maritime provinces. But we have a pretty decent warm frontal cloud head over and north to in the east of the Maritimes. And then the cold frontal boundary probably has some integrity all the way almost to the Bahamas. It certainly will demonstrate that it had some thermal integrity off the whole peninsula. Wednesday it was 83 in Miami at 10 a.m. or something like that. Today it's 61. So it's very different complexion. And you can see the stratocumulus over the southeastern Gulf of Mexico too, very obviously a result of cold advection. So things have changed in the eastern half of the United States as a consequence of this big disturbance. But the peril that was forecasted here, and certainly at a time was a reasonable thing to be bringing up, was should have been relaxed, I think, a little bit more in the immediate hours and day, the one day before the event, because it was clear it wasn't going to quite happen the way that some of the prior forecasts had suggested up to that point. And then I think when we see on the radar across the continental 48, there's only a few places where some of this cloudiness is precipitating. I think one of them is down here over the Virginia and the Western Carolinas, a little bit of Tennessee. And then there's a little bit of precipitation in the Southwest. But broadly speaking, this is one of the least precipitating 48 contiguous days of the year. I think we'll see that in the radar.
I got a report from my mom. She texted me that there was a little bit of light snow in northern Baltimore City.
Oh, is that right?
This morning, some really tiny flakes you're saying. But also on the radar, we'll probably also see an area of snowfall to our southwest, just over northern Illinois and south.
Yeah, it's still snowing there. Yeah, it's snowing there. And the broad northerly flow, you can see even in the visible, it's clear these cloud elements have a track heading south and southeastward. And that's going to keep us cold for a short period of time. It's not really cold, but cool. And then the weekend, as you'll see, the weekend's quite nice looking. And next week will be not, I don't think quite as cold as this week, but broadly similar.
And one last comment, perhaps on the storm that went by, or the cyclone that went by. It produced, I think this was the one that produced a band of snow that was probably no more than, I may have texted you and see it, Greg, 30 miles wide or so, but with a maximum of 13 inches in the heart of it, which was just impressive. And how you get that, how well that's forecast by mesoscale models, I don't know. But
Is this the thing you're talking about, the Nebraska, Kansas? I heard that was 8 miles wide.
okay, but those 13 inches in the
There's a image from an aircraft if you want.
Right.
Yeah, I've seen that
The
too.
one on map.
Maybe it was a map thing. I know I saw this earlier this week, but it's possible to, maybe if someone can send it to Pete, we can bring it up later, but that was just a really impressive.
Yeah, that is pretty impressive.
Man.
So that means the half width is like 10 kilometers.
Yeah.
Just next to the TP.
And the half width is the distance from the axis of maximum precipitation amount to a point that gets half that much. So it's probably even 5 kilometers, which is exceptionally mesoscale. That's not,
Here's the
that's
snow
not normal.
showing up.
Right, so is that band right in there, that very thin
Talk
band?
about being in the right place at the
Yeah,
right
right.
time.
Oh, wrong
And
place.
people on other sides are like, we didn't get any snow, it's
Yeah.
all important.
That's really awesome.
Anyways,
Okay, let's take a look at the West Coast satellite if we can, Pete. After we get out of your psychedelic satellite
I
pictures,
resemble that. Right?
I'm so enamored with
All right, so we're going to this.
it. Yeah. So one of the interesting things on this map is the development, and I had a 12-hour image movie this morning in class, where this cloud head crashing in between the Queen Solids and Vancouver Island on the British Columbia coast really takes shape fast. 12 hours ago, I was looking at 10 a.m. And so 10 p.m., there's plenty of cold air back here in the Gulf of Alaska. You can see that in the open cellular convection. But this thing was not really well developed, and then it rapidly puts itself together. I don't know what the sea level pressure is like. We'll see that on the surface map when we look in a minute. But it's a beautiful comma shape with a nice tight circulation center just offshore of the coast of British Columbia. That's the main feature of interest in the eastern Pacific. Again, the tropical is Hawaii, to give you an idea, that's about 23 degrees. So we're deep in the tropics here with this line of probably weak thunderstorm, maybe a little bit stronger when you get over to these longitudes. And then maybe there's some weak connection between that activity and a little bit of this cloudiness at least, and therefore some water vapor transport forward towards Arizona and eastern California, southeastern California. And then there's this big disturbance getting itself organized. Maybe it's an amalgamation of a couple of different ones at about the date line. Obliquely, one can see some really chilly air, evidenced again by the popcorn cumulus, well to the south. I mean, this is way down at 35 degrees north or something. So there must be a spilling of really cold air out over the Bering Sea and Kamchatka Peninsula. Again, it's a great way to get rid of cold air in the northern hemisphere in the winter times, to just let it flow over the water. It's going to disappear relatively quickly. And I'm beginning to wonder if that isn't one of the reasons why we have interannual variability in the seasonal average cold pool extent. That some years, for whatever the reason is, the circulation sets up to dispose of the cold air over the hot plate, and other times it only makes itself in migration over the land, or at least preferentially. And that might be a difference, but I don't know what that would compel that difference. Today will be the last day of my 90-day sequence. I don't count February 29th. And up through the 24th, we were still in third place all time. I think we'll probably end up in third place all time. I don't think someone's going to overtake us. We won't overtake number 2. We certainly won't overtake number 1. But it looks to me like by the end of the day, we'll be the third warmest winter in the last 72 years of the NCEP reanalysis to the current time in terms of the 850 millibar seasonal average cold air extent at -5 degrees. So that's pretty remarkable. And December, as I've mentioned more than once, December was the all-time warmest December in that 72-year time series by that measure. And we lost a little ground in January and February. But nonetheless, coming in third out of 72 is pretty good. You'd still win a bronze medal.
If there were an Olympics.
Yeah, well, Ketzel Levens just was in the Berkbiner upstate. There's 2,000 people who were in her class of the races. She was 15th. And I said, is there any hardware? No, first, second, and third, the only place to get hardware. Terrible. 15th out of 2,000? So anyway, if we have a 2,000-year time series someday and you get the 15th warmest winter, that's noteworthy.
It's called the Ketzel winter.
Yeah, that's right. So 3 out of 72 is nothing like that, but pretty good nonetheless. Okay, so what we want to do next is look at our surface map so we can get an idea of what that thing looks like, and then just take a nice view of the continent, which is enjoying a day fairly free of precipitation.
And if we could, at some point, after looking at the one off the West Coast one, is look at the little disturbance that's going by just south of us. It's really neat. It's right along the front. There's a little cyclone.
Oh, I hadn't seen that. Okay, yeah, you'll have to point it out. So here we are in our own region, very dry air with light northwesterly flow, 2304. We're about the coldest spot in the country. I mean, it was 2 degrees this morning in International Falls. It's warmed up to 19. There's no place else that's really as cold as us, except maybe some high elevation locations, and even those are probably warmer now. I don't see any of them reporting temperatures in the teens. Here, near Yellowstone, it's 18. So that's comparable, but that's a little bit higher elevation. But that is underneath also the anticyclone that's sitting there. It's migrated southward from Western Canada. So light snow in Virginia, West Virginia, sorry, and some light snow in the lee of the lakes at Erie and further to the north, further to the east. Some light snow north of Bloomington, and a little bit of snow in the upper peninsula, lower peninsula, and the upper peninsula also get light snow. So that's about where the snow is falling across continental U.S., with the exception of far northern New Hampshire and Burlington. Vermont has a little bit of snow. Heavy snow in Syracuse. Is that Syracuse, Ithaca?
No, that's further, a bit further south.
I think that's Watertown.
Oh, Watertown. Yeah, that's a famous
Right.
snow place.
They're expecting
Wow.
from that, again, it's from that same storm we've been talking about a lot. I think upwards to 3 or 4 feet of snow. I don't know if it actually manifests itself, but it's fake, right? I mean, it's real snow, but it's just lake effect.
You can run a business on that fake snow if you remove it for people for free. So you should keep that in mind. Here's the longest possible fetch on Lake Ontario, and the wind is right along that edge.
Right.
It's perfect. That's great. So that's pretty awesome. That's the only thing beyond light snow that I see on this map.
Could
Anyway.
we, sorry to interrupt. Pete, can you bring up your Midwest maps that would focus in on,
Yeah, because I didn't know what you were talking about, Mike. I hadn't noticed that.
yeah, it's not really showing up in the, we should see a few snowflakes,
There's a few in Illinois that weren't on the.
right, further to the north, but northwest, to the west there.
Oh, yeah,
Station right there.
Okay.
And earlier, a couple hours ago, there were a few more reports of snowfall there, and it's really interesting. You can even see it.
Oh, yeah, there's snow, and this is Rockford was snowing
Right.
this morning, light snow.
Right, and you can see there's a little bit of a weak cyclonic circulation, that southerly wind just
Right
right
in here,
in there,
maybe?
yeah.
Yeah, maybe that's true. Let's see, 1018.2, 1018.9. Everything else is higher to the west, to the east. Yeah, so and when you get over here, you're kind of on the western side of the bigger cycle.
Right.
So, yeah, that might
It's
be
a
a
little
little disturbance, yeah. I like
Disturbance.
that.
It's
Did you
actually
see it
picked
in the
up.
satellite or anything?
No, you see the band of cloudiness there, but in the sort of forecast, I was noticing, I was shocked, I was looking at, we'll see this when we look at the M5 runs. You can see this band of snow. It's like, I don't recall that being there. That must be an artifact of
I like that.
something weird, but it shows up pretty well.
So I'm gonna guess at 500 millibars, we'll see a pretty strong northerly flow, and then maybe the hint of a little bit of a curvature maxima down in this location, maybe even a little bit to the west at 12 feet. Let's see. So let's go to the radar first.
Oh, do you want to go to the west coast to see the?
Oh, yeah, I don't think I noticed that there's no obs off the coast, so I don't know what the pressure is offshore, and that storm was kind of
Further up.
up along the British Columbia coast. It was right about here, and so I don't have any obs now. It's at least 1,008 far removed from it, so I don't, it's too bad, I don't know what that is. Maybe we'll have to just rely on the analyses and see what's going on there. But let's take a look at the radar next. So here's our, look at that. That's your heavy snow in Watertown. That is a beautiful band, but maybe it's migrating northward of the station. I don't know, but that's been snowing like crazy. Some of it's spilling into the light snow in Burlington. Same with like Dixville, Notch up here in northern New Hampshire. And then the mitten hand of lower Michigan has some pretty decent lake effect and a little bit near Houghton as well. And then here's some of the scattered snow. And maybe you can see even where it goes from snow in northern Illinois to rain in southeast Missouri and central Illinois. I think it was raining south of St. Louis. And then here it's light precipitation, most likely liquid form also over the high Appalachians on the border of North Carolina and Tennessee, Knoxville area, and then northern Georgia. And then there's a little bit of light snow across Maine, but who's there to report it? In this part of the state, nobody. Absolutely nobody. Have you ever been to central Maine? I mean, it is a vast building. It's like a mini Alaska. And then here's some echo in the valley. I'm not sure what's going on there. I don't think it's precipitating yet, that's for sure.
And then that,
Some strange structure that's near Area 51 in New Mexico. We won't worry about that.
and those showers near the British Columbia coast and.
Oh, yeah.
Cyclone.
And so that's the eastern edge of the cloud mass, it seems to me, for the storm that's well out, probably about there. So let's take a look at the 500 millibar map first, if we could, Pete. Yeah, I can neither confirm nor deny there's anything going on in New Mexico today. So here's our northerly flow at 500 this morning. It's characterized by cold advection sort of over southeast Missouri, southwest Missouri and parts of Kansas, and then warm advection upstream. And that's characteristically the case. The closer you are to the ridge axis, the more likely it is to be warm advection in that northwesterly flow. And it's more likely it's cold advection down near the base. And that tends to amplify the downstream trough and helps to at least preserve, if not amplify, the ridge. So one maintains the broad wave shape, but it exacerbates the intensity at both ends in the face of such temperature advection regime. Here's the northerly flow off the coast. So here's Vancouver Island and the former Queen Charlotte Islands. They have a native name now, which I don't remember. And then, perfect. Here's our cyclone developing right there. It's got a nice upper wave, very sharp curvature maxima, shear vorticity maxima as well, and a very strong horizontal thermal contrast. It's minus 38 in that cold air that we saw with the popcorn cellular convection there on the southeast Gulf of Mexico, Gulf of Alaska, sorry. And then this is minus 25, this air right here. So that's a really sharp horizontal temperature gradient at 500 millibars. So a potent upper wave and a nice development. Looks a little bit like November 2019, but not as intense, but some of the same elements. And here's the broad upper cutoff that's sitting over southern Quebec and controlling, the weather over a large part of North America, but certainly controlling the cloud development in this region off the Maritimes. There's a cold front tied to the cyclone that's related to this upper wave, and then broad subsidence everywhere to the west of about a line like that, and we saw the perfectly clear skies across the Central Plains, and we're enjoying them outside here today. Okay, let's go to.
I was going to have to back up a second. If I were to show you this map, it seems to me, I know it's end of February or nearly the end of February, but it seemed like this would be a map you would see and say, it's pretty cold across the eastern United States.
Oh yeah, and my eye would be drawn to 5,000 feet.
Right.
That's a low geopotential height.
And things have receded a little bit. It's moved more to the east, but it's not impressively cold outside.
No, we had nothing below zero anywhere in the eastern half of the U.S. There was 2 at International Falls today at 10 o'clock. It might have got below zero overnight, but it's not desperately cold. You're right. Testament to the sun angle. It's late February, or testament to modification of cold air that's maybe funneled in under this trough. Or one other interpretation is, here's the boundary of the polar vortex. And this thing is just a stray that's taking its time coming southward over, the land that's starting to warm up. So I don't know. It's an interesting point that you make. So yeah, that would look like a deep, late January deep cold snap. But very broad scale, which I think shrinks the impact of how cold it can be. And that's just beginning to evolve in my mind as a way to differentiate cold spells. But it is a really dominant feature of the circulation. It's a great white spot here in North America.
Oh, maybe it's also the fact that this was amalgamation of these two separate features that one originated very low latitudes, the other maybe more mid latitudes. And what we're seeing at 500 millibars, the low geopotential heights, is more manifestation of a lower tropospheric vortex that's really intense. And it's, if you invert the PV associated with that, it gives you those low heights there.
Oh, yeah.
It's not controlled by something that's more akin to a piece of the polar vortex.
Yeah, so it's sort of upside down.
Yeah.
Sometimes it's the other way around. Yeah, that could be. It could very well be. Yeah, that's a good point. So that's 500. Let's take a look a little higher. Let's go to 300 millibars. We get some idea of what the jet structure looks like, but only some idea. We'll have to go higher still to figure out what's going on here on this southern and eastern periphery of this broad upper cutoff. This is most likely a polar jet feature, and then there's definitely a polar jet feature in the northwesterly flow to our west, and we can see that even in the visible satellite image. And then this feature again, undoubtedly a polar jet feature on the western side of this fairly sharp upper trough that's spawned the cyclone off the coast of British Columbia. So that's an interesting feature. If we go a little higher, if we go to 200 millibars, how much of, even at 300, we see 111 knots off the coast of California. How much of that subtropical jet is in this feature here? I don't know. So let's try and go a little higher. So this was 147 knots at 300. It's 146 at 200. I bet it's higher at 250. Let's take a look. No, same. So this is a deep kind of 140 knot jet, but one can see there is a connection, and this feature off the Pacific coast gets stronger with higher elevation. This is 250 now. And so there's little ridginess. This is definitely got elements of the subtropical jet, a zonal subtropical jet across far northwestern Mexico. I don't have enough experience to know if that's unusual or not. It seems like it is, but I don't know. And then it may be characteristic of this time of year, the transition into the late winter and early spring. But there's a broad jet feature here. It'd be interesting to cut a cross-section through it. I imagine a deep, kind of uniform 140 knot ice attack that spans all the way from 200 millibars to something like 350. And so maybe one sharp tropopause drop from the tropical side to the polar side characterizes this jet. So I'm not sure.
Once we're done, we can actually go to tropical.
Yeah, that would be fun to do that. We can do that for sure. And then this thing is weaker, but still in the same location. So one imagines the higher one goes from 300 millibars, you're just moving through the column of high wind speeds to lower and lower ones. So the core is lower than this. And that makes me think it's a polar jet. for sure. And the same is true here. This is stronger at 300 millibar.
That feature off the west coast, the maximum in temperatures right there is probably indicative of you're right above a nice PV anomaly.
Yeah,
Low
right. This is a low tropopause. So you're in the lower stratosphere here and it's warmer. Look at that. It's minus 60 to minus 46, 14 degrees across there. And it's it's obscured by the wind bob. But this is minus 56 in interior British Columbia. So that's 10 degrees at least. Probably something like 10 right there. So a lot of lower stratospheric warm advection, which tends to be associated with development. That was one of Dines' first ideas in the 1910s. There's dynamical reasons that are better than thermal reasons for that, but thermal reasons are interesting. So let's take a look at 850. So we've gone up from the middle troposphere. Let's go down to 850 and see what the thermal field looks like in the vicinity of our storm. So first, this is a not so well organized cyclone. It's a broad upper trough we've already seen. There seem to be two centers of vorticity in the lower troposphere. The one that's further east has a decent baroclinic zone with it, but it's really not frontal in the sense that there's a second derivative of temperature gradient or temperature here. There really isn't that. Maybe there is a little bit along the warm front, and that looked like a more obvious cloud shield in the satellite. This thing is struggling dynamically to stay together, especially if you go farther south and southwest of Bermuda. But nonetheless, there is broad but weak cold advection across the peninsula, and the consequence is a 20-degree cooler day today than yesterday over southern Florida. And then here we have a nice cold upper trough, and then on the western side of it is the salvation for the weekend. That is a strong horizontal temperature contrast that will be exacerbated by flow over the high terrain. We already see a little bit of a weak, let me draw right on this. I can't tell the geopotential heights. They get higher. This is a ridge, so it's going to be replaced by a little bit of a lee side trough that'll exacerbate the warming right here in the western part of the plains. And then the flow will turn around, we'll see, from northwesterly to more westerly, and that'll be a warm advection regime for us and get us warm pretty fast Saturday and Sunday.
But you're gonna need that westerly flow to start, because right now it's still kind of right along the.
That's right. That's exactly right. So yeah, at 500 millibars, the flow is about the same direction. Later on, it'll turn a little bit more across the high terrain, and that's what we need to get this all going. So if we could, Pete, why don't we just go to tropical tidbits and draw a cross section through that jet on the east coast, just to see what it looks like. This is a nice page, except they need to have more options for cross sections. They have about 5 different things, and 3 of them step all over each other, so there's really 2.
I don't use those very often, so you're gonna have to.
Okay, yeah, let's go to regions. We'll get a little bit bigger than just I think we'll get
Like North America.
Yeah, that should work. I don't know if it allows us to draw cross sections. No, it doesn't. Unfortunately, we got to go to another one. Let's go to North Atlantic, and that surprisingly that'll still contain the coast. And when the cursor shows up as a cross, then you know you can draw a cross section. So let's go down to the variables, upper dynamics. We'll do 200 millibar wind, and then let's cut right through there. And you do it with control. I think it's control, and you just drag along the line. And then come down this way. Okay, perfect. And then let's do PV. That'll give us the wind speeds too, and then we're going to submit it. So it'll be a little panel here to remind us where we cut the cross section. So it's quite a nice device. So there's our cross section, and this is really sort of an ugly field. Although here's the 140 knot isotap spanning from 300 all the way to 200. It's kind of what we saw in our horizontal map. The PV 1.5 surface, I think, is the dashed black line. So it's really confused over the northeast part of North America. But it's a steep jump from down at 400 millibars all the way up to 100. This is what looks characteristic of these superposed jet structures. I don't know if this is actually one of those or not, but it's an unusually steep tropopause jump from a polar tropopause height to a tropical tropopause height, and a really intense wind speed maximum. So it may be such a feature, but one of the weaker type versions.
Right, and that's kind of messy. You know, the messiness there. Those small blips typically don't have much meaning in terms of impact on the flow. Because if you were to go from the PV to a height or temperature field, you're going to see that gets smoothed out. It's going to be much.
Yeah. I was telling Giorgio this morning, this is what you do if you come across these things in your data. Just throw a Laplacian around it and see what happens, or invert. Do a second order inversion, and they go away, and all you see is the big structure, and that's kind of where you gain insight. So it's just what Michael said. So it's an interesting jet, not the strongest, if it is a superposed jet, not the strongest one I've ever seen, but it looks like it may well be one. We've been using 315 to 330 for the polar jet layer, and that would be here. And so certainly there's a PV gradient and a wind speed maxima there. And then 340 to 355 goes from here to this isentrope. So again, same thing, strong PV gradient, strong wind speed maximum, and they're about in the same vertical column. So it's probably a superposed jet. And they're not particularly strong. And when I say superposed, I mean polar and subtropical existing in the same vertical grid column. And when that happens, you tend to get stronger horizontal velocities and stronger secondary circulations associated with them. So they tend to be a little bit more potent than strong polar or strong subtropical jets by themselves.
What is that, wind max from near point A?
Right.
No, right about that.
Right there, 50 knots? Yeah, that's interesting. I don't know. It's the other side of an upper trough, so
Yeah.
let's see.
Point A is from point A.
Here's the upper trough, so it must be northeasterly flow at 600 millibars, right about like that, coming down this way.
Yeah, you can see that since those are solid contours, dashed is into the
Oh, okay.
to the page, so the solid ones are out of the page. So
Oh, yeah.
it's on the other side of the upper trough, as John was saying.
So do you think that that's all noise? There is no trouble for folding?
It doesn't look like there's an obvious fold here. No, there's just a really strong step. It'd be interesting, looking at this, to go back in time and see whether or not at a prior time there was a fold. There's a decent baroclinic zone, but it doesn't really look frontal. It's not really intense either in the horizontal or in the vertical. So the stability is not large and the horizontal gradient is not really large, like you sometimes see in these upper front stroke fold structures. But I don't know from just this one picture what the history looked like leading up to this.
You can step back in time in the bottom corner, you're not moving the cross section.
Yeah, that's the problem. I think we might not like the next cross section. Let's see what it looks like. It's okay. It's a reasonable one. But we still don't see any of that really clear tropopause fold structure, because the polar tropopause resides around 400 millibars. You want to see it extending down to lower elevations, higher pressure. Okay, that's all I have.
Okay.
Michael, you want to tell us about the forecast?
So like the last several weeks, it seems like it's going to be another quiet weekend. Probably one devoid of precipitation. We'll first look at our time height section. We'll skip the meteorograms for today. We won't skip it, we'll actually go back.
This is a meteorogram, right?
This is the cross section. In fact, let's actually go back to meteorograms because I know John loves those maps so much. So again, trend like we've seen just about every Friday for the last at least 2 or 3, upward trend in temperature. So we're going to be warming up, dew points are going up, and very little in the way of precipitation. I'd probably generally discount this. This is over 60 hours. Again, this is a time series running from 12Z today to 0Z on the second, so Monday 0Z, so Sunday evening. So dry weekend, warming up, which is really nice. And we'll look at MOS, the GFS MOS, just to get a sense of what the actual temperatures are going to be, not using just the 2-meter temperatures that come out of the model here. But upward trend is what's anticipated. Now we'll go to the time height section. So time height section, the yellow lines you'll see are going to be isentropes. And here's our dynamic tropopause, the 1.5 PVU surface. You can see that it's actually retreating. Heights are beginning to rise. The tropopause itself beginning to lift over us. You can see early in the period this afternoon, even with the snow cover and such, we're going to get, with full sun, we're going to get some mixing occurring. So we get a nice well mixed layer even over the snow cover that still remains. I think at least the analyses still have us at about 6 or 7 inches of snow on the ground. That might be a bit much.
I think we had 12 inches of snow cover on the weekend, last weekend, for the first time in 3,000 days.
Oh, well.
It's been a long time since we had that much snow on the ground.
No,
I didn't. My friend told me that.
Okay.
So I haven't verified it, but it sounded so authoritative, I figured I'd report it.
Okay.
10 years?
Yeah, 10 years.
But anyway, it's a long time.
It's about 8 years, yeah.
Right. So, kind of the appearance of a well-mixed layer that shows up, and then the mixing is less deep tomorrow's stratification begins to increase on us. That might be partly the effects of some subsidence. You can see some weak subsidence here on the light blue, negative omega being plotted here. So that's actually those negative values do indicate subsidence. And then ascent beginning to occur later in the period. But again, dry column gets a little bit moister, maybe more moist in terms of not actually moisture, the relativity is going up. But we'll see that there's going to be a transport of water vapor from lower latitude. And this, with the increasing stratification and probably we're also keeping some of the moisture trapped in near the surface layer. So that suggests maybe some more cloudiness over by the time we get to Sunday during the day. But again, really a dry weekend and nothing really significant occurring over us, at least based on this map. Let's next go to our PD, 305 to 315. And we'll first just start off with a single image at 6 hours in the forecast, please. See this nice deep, associated with a deep trough this large. I hate to say it's ridge in PV, but it's the trough, right? Trough that we have over the eastern part of the United States. And, as we'll see in the evolution of this trough will just, sort of gradually eject itself off the east coast of the United States. There's also going to be some erosion looking at the PV associated with some diabatic heating. You can see where sort of the isotropic surface here sort of outcrops over parts of Mexico just because of the warming. And there's that nice trough that we saw off the west coast of the United States approaching, and British Columbia approaching the west coast. John was looking at that earlier. So really nice local maximum potential vorticity out over the west coast. Let's go ahead in 12 hours to 8 hours of forecast. So midnight tonight. Here's the trough continuing its progression eastward. We saw the dynamical tropopause, the heights begin to, the height of it begins to lift as this moves further toward the west, as this broad ridge begins to encompass the western part of the United States. Also, we'll see at this level, westerlies beginning to arrive across the western part of the United States. And we know those westerlies, this is an isotropic surface, but we're going to see through the lower mid-troposphere, we have this westerly flow. That sets the stage for creating with the subsidence on the lee side of the Rocky Mountains, warming, and that area will eventually be ejected over us for a nice warm up coming up. Let's go ahead another 12 hours to tomorrow. This time, and westerlies continuing. And notice the east side of this, eastern side of this trough, where we're seeing an erosion of PV on the leading edge of the trough. That's evidence of some diabatic heating. We'll see that there is, in fact, significant area of precipitation that breaks out along, I guess, a redeveloping front that's off the Atlantic coast. But that troughs away. Here's the westerly flow, just about every latitude across the western United States. So that suggests a trough at 850 millibars, and lee side warming. That's really nice for us.
Just, looking at this one picture, it's a great qualifying exam question, because you could say, where's the anticyclone at the surface going to develop? Where is the low-level warm air going to develop, and why? And what does that mean for Madison at day +1? And you can answer it all by looking at this one picture.
Yeah, what's going to happen next?
Yeah,
pretty much. So this is really exciting.
Forecast in the 60s. Forecast in the 60s.
It's pretty warm anywhere. I don't think that.
Yeah, so let's go ahead to what time is this? 30 hours to 42, and then we'll just loop it after that. Okay. And still continued westerlies here, and last vestiges of sort of erosion of that PV on the eastern side of the trough. But this again is a kind of pretty quiet weekend that's setting up. It's also interesting to note that really nice trough that was off the west coast of the United States is now moved inland and it's sort of absorbed into this larger circulation, so it kind of weakens, falls apart. So we're probably not going to see much associated with that. Let's animate this, please, Pete. First thing I'd like you to note is on the eastern side of that trough that's off over the eastern part of the United States. Again, we see this erosion. And again, why do we look at this? One of the, there are 3 characteristics of potential vorticity that make it kind of important. We need to talk about this in 311 today. One is just its conservation for adiabatic and viscid flow. And so on this particular map, features that we see, we should be able to explain their evolution purely through advection in this isentropic layer. And if we can't explain that feature, it means either there is diabatic heating occurring or the effects of friction destroying the potential vorticity or redistributing the PV. The second thing is, why is PV important? It also controls the large-scale dynamics. It's one of the most important dynamical variables for geophysical fluid dynamics, where we have maximum potential vorticity. We can infer things about the wind structure, and if we look right across the vertical, we can look at temperature structures associated with it. And finally, this notion of superposition. You can bring like-signed PV anomalies closer together, and they become more energetic in terms of their total energy. But just a really nice variable to look at, and we can see the advection of these features. There's that upper trough as it moves eastward. Again, it don't lose too much in terms of its structure over time. Also notice how the winds turn from more northwesterly, as John was noting earlier, to more westerly as this trough and this whole feature moves westward, pretending an increase in temperature for us once the air affects over us. So the timing of the erosion, this PV, is around 24, about 30 to 36 hours. Let's take a look at the surface maps. First, we'll just step through the surface maps really quickly. 6 hours. Again, here's that light snow that was forecast by the models, by this particular model, as well as the UW-AOS and GFS, just to our southwest, relatively light snow. Here's some upslope snowfall on the upslope side of the Appalachians with that west to northwesterly flow. You can see it lining up there pretty nicely. And that pretty decent cyclone making landfall in British Columbia early this morning. Okay, so let's step ahead 12 hours. Okay, the area of snowfall continues to move southward. There's a hint of a curvature maximum along this, but even when you're looking at the maps, John, at 500 millibars, there's not much. The vorticity doesn't really have a nice ball to it. So this is really a lower tropospheric force structure. But there it goes towards south. But again, with the so this is now less. A little bit of this is still upslope, but this is more forced by this really weak curvature maximum that appears to begin to break out over Tennessee and Kentucky. And that cyclone evens a little bit further from about 1,004 down to 1,000 up to 997 as it moves to the western part of the United States. And you can see at least thickness affection, the warm thickness affection really beginning to set up as this anticyclone moves to the south east.
It's gonna be mixed rain and snow in Seattle maybe at this time.
Yeah, what's the peak period for snowfall in terms of precipitation type being snow?
Oh, for the
For
season?
Seattle, yeah.
It's usually earlier February, late January, February, but 528 thickness is sometimes the right boundary, so it's just about there. I don't know what the actual vertical temperature structure looks like, that's more important. 528 gets you turning your head.
Okay, so let's go ahead to 18, 24 to 36. Okay, so 30. Okay, I mean, precipitation along this front, that's out over the Atlantic, but it really seems to really get going just off the southeast coast. And this is just about the area where we saw the reduction in PV in the lower troposphere, so that we have that evidence of diabatic heating. Here's our thermal trough that's set up and our thermal pressure trough and our thermal ridge that's associated with it. So you can see warming that's occurred with that westerly flow that we saw at higher levels above this on this map. So this is the warming that's occurring, and we're just downstream of it. So warm advection coming in earnest. Tomorrow will be warmer. We have warm advection occurring, but Sunday perhaps even warmer than that. Let's move ahead, please.
Thank the Rockies.
Yeah. Well, they don't want to play against them, right?
No, you would anywhere except Mile High.
Right. Okay. So this is tomorrow night, midnight, we have warm advection occurring, so it could be still a relatively mild night. Temperature's going to drop off, obviously, but it's not going to drop off precipitously with a strong southwesterly wind. We'll look at the close-up maps in just a second. But that thermal ridge is now beginning to move away from the Rockies. And we'll go ahead one more time period to end it. We have 60 hours, we'll just end it there. And here's the warm advection over us, just about over. You can see this difluent flow that's developing. There's a weak cold front that's going to come through during the afternoon on Sunday. Looks like it's largely going to be dry, but there is a little bit of precipitation around Green Bay and north of Sheboygan along the west coast of Milwaukee, at least forecast of Wisconsin, Lake Michigan, excuse me, at this time period. And cyclone Gabriella in the Central Plains at this point. So let's look at these close-up maps that we have. And I just want to go to 3 hours in the forecast near the surface. So here's this really curious feature that shows up. You can see evidence. I mean, there's certainly a wind shift along this. This is a front, right, to a cold advection here and a neutral advection. So some of this might be confluent frontogenesis forcing the snowfall. It's a really shallow feature, but there's also just, I think, evidence. We saw that in the sea level pressure. Just a really weak minima right along the leading edge of this, or just behind where the dissipations occur. But, you know, the models, it's kind of interesting, this 90-kilometer resolution model we've been running forever picked up on that feature really nicely. But it's right along the Barrett Plain zone. I expect that to head to the zone. Our cold advection is really, this is neutral, essentially neutral advection at this point. Let's go ahead to tomorrow this time. So 27 hours. Yes, sir. 3 plus 24 is 27. So that's 15.
All right, fair enough.
Thanks, Steve. But by that time, you can see the warm advection is really spreading the ridges to our south into the westerly flow with warm advection coming in. A little bit of maybe lake effect snow just off on the eastern shores of Lake Michigan, but we're going to begin our warm up. Okay, let's go ahead to tomorrow, late afternoon. So we'll go to 36, just around sunset tomorrow. Again, 5 to 10 knot winds out of the south, warm advection, not really strong warm advection because the angle isn't great across the isotherms, but warm advection occurring over us by this time period. Even the northern part of the state, I mean, 20 knots is going to be kind of a breezy, warm day, or warm evening tomorrow.
What model is this?
This is the MM5. We've been running this in this configuration since 2001, I guess. It just runs, just set up, it just runs, just let it
No
go.
longer any control.
Yeah, we can't control it, it just runs.
It's down, it's running down. It's a down 9 pound.
Or an old Palm Pilot, maybe. Let's go ahead to Sunday morning, 48 hours. Sunday morning, this is kind of a really messy. Temperature field.
Or something, there's a lot of waves.
Yeah, but it actually disappears over time. So I think the pressure for the temperature feels like relatively flat at this point. So these are little areas where they're suggesting there might be precipitation. I just think we're getting close to saturation. For microphysics, it might be an issue with the microphysics back into the model, but I don't anticipate we can actually see liquid precipitation or frozen precipitation falling for that matter. But you can see these winds are still 5 to 10 knots out of the south, so it's going to be, I think, going to cool off a lot. Let's go. You can see the beginnings of that front that we mentioned earlier. You can see the wind shift. Not much of a temperature gradient at this point. Let's go to late in the afternoon. We'll go to 54 hour. Actually, let's go to 60. We'll just end it. And so by this point, nice confluence. You can see the the confluence shows up nicely. You can see the front is just about to pass our area by the time we get to Sunday evening around 6 o'clock. This is a guess, inverse from looking at these maps earlier, that this, you have the warm advection occurring, but we sort of stubbornly, these boundaries don't seem to be moving north for the isotherm. I'm wondering if this is the effect of the snow cover on the surface, just helping limiting the retreat of the snow edge and the cold air. So kind of cooler than we otherwise would be, but you can see even at this time, we have temperatures 10, 12 degrees Celsius, if you want to believe those numbers explicitly, or up to 54 degrees or so in southern parts of Iowa. It's probably warmer than that. I imagine you could actually look at the Moss numbers for some of these locations. We'll check out Moss in just a second. But again, the nice nose of warm air just ahead of the front, and then we begin to cool off, and that'll be the story for early next week. But not much in the way of precipitation at all forecast for this. Let's take a quick look at the GFS. You'll see the timing on the frontal passage is about the same. Let me go to pivotal. Yeah, you already have that panel up right there, third. Yeah. Fourth. No. And we're 12Z, go to the surface, and then we'll go to 60 hours. This is the end of our 5 forecast time period. Again, nothing in the way of precipitation here. You can see the transition across the leading edge of this. The front's maybe a little bit faster, perhaps looking just judge all the thicknesses than we would have seen in the we saw the MN5, but here's the cold advection, the real strong cold advection well over northwest of us. So we had a really nice weekend shaping up. And that large area of cyclonic circulation we saw on the Pacific coast, that'll become a more concentrated cutoff. And as John mentioned, I think a couple weeks ago, this is kind of the time of year for cutoffs to impact the southwestern part of the United States. We'll go ahead to 84 hours of the forecast. Let's get this to Monday evening. And you can see the cutoff moves on shore, but cold advection, it's not super cold. We're going to get a little bit colder thickness wise, but we stay dry through the early part of next week. So Monday is going to be also a dry day. So pretty quiet weather going forward through at least the first part of next week. We do a couple quick things. We just go ahead 24 hours in big chunks of time. So we have that 24, 108, yeah. Tuesday. Again, beginning to see lots of precipitation and convection in the southeastern United States. And we're cold, but not super cold.
The Storm Prediction Center actually has an outlook for that convection
For this,
No, further south,
Further south.
Texas, Louisiana, Mississippi,
Okay.
and southern Arkansas.
and that's as that cutoff, I guess, finally, looks like it's falling apart as it crosses the Rockies, but
But the Euro has such a drastically different solution that they're kind of more just saying, well, there's moisture at a boundary, so maybe something will happen.
let's actually look at the European forecast for this same time period. They're looking at
It's
Tuesday,
quite different.
high res, please, yes, on that.
Oh, wow, yeah.
And even just the placement of the upper level low, it's still quite cut off versus in the GFS, it's kind of absorbed into the.
It looks like this has just moved much more rapidly toward the east.
It's held back slower, so that low you see in Mexico is pretty much what the surface low is for it.
Okay, let's step ahead a little bit with this solution, just to take a quick look. The Europeans will merge. Okay, gonna ride along. That's really weird. Let's flip back.
Go to
to
500 on
Okay.
that, you'll see how bizarre it is between the.
Yeah, just click on that for a second, Pete.
It's.
We live in the age of powerful NWP,
Yeah.
but lots of differences. Okay, so 500 millibars. Really nice, strong trough right here off the, in the southeast United States and East WF forecast at this point. Wow. And we're looking at less than, just over, 2.5 days or so. Difference.
It's like 90 day.
So that's really weird. No, the interesting thing about this trough, and it shows up in the super peaks that were shown earlier where John was going into the discussion. I was expecting, I knew in the forecast by the time we got to Sunday that there'd be a cutoff off the west coast of the United States, off of California. But if you look at the map, I was expecting it to be a nice, well-defined cutoff somewhere out in the Pacific. It's really this elongated area of
Yeah.
lower heights that's out there, which is kind of a weird structure. And I'm wondering, it's just a matter of how things came together. This elongated area of lower heights will probably also extended PV anomaly. How did it all roll up? That would be something that might be of interest to look at, but not today. So big differences in the forecast. Maybe we can at least say with some confidence that the next 2 to 3 days are going to be dry, but over us. But when we begin to see differences like this, and if we go to GFS, let's just look at the difference one more time in this cutoff. And then if you look at, I'm curious, I'm going to guess the Canadian model, the GDPS, will look more like these WFP. And the reason for that may have something to do, I think the Canadians still use a 4D LAR type system for their assimilation, and maybe the differences in how the data gets assimilated may actually have an influence on the overall forecast structure. And the European Center, I mean, not the European Center, UK Met, we have access to that as well.
Yeah, it's like the claw.
The dinosaur class, channeling my inner Melissa.
UK Met, that's available, that also has this. Now, just note UK Met, I don't normally look at this model, but now that it's been available on Pivotal in the last few runs, this was the one that had the sort of the first ideas of that snowfall that we had, those forecasts for us last weekend that shipped to the south. I think by Sunday afternoon, it was already south of us and never came back.
This is another setup that reminds me a lot of what we had, except things now at the same initial stage are positioned to be resolved. You know, you got the upper front and the northwesterly flow, and you got the cutoff to the south and east. And now they're over the continent. So what happens in the future on these?
Let's go to 144 hours, maybe when if we do that, it'll jump to the ECWF model.
Well, that's not what I expected. But if they can get their act together, it'd be a massive event on the East Coast.
Right, and this is the superposition idea. These two, if you look at these as in terms of their potential vorticity, they're both cyclonic potential vorticity anomalies. You bring them closer together, you get something that's more energetic. Does the ECWF have a similar forecast?
Canadian would also be interesting because they look like they're most poised for.
Yeah.
That thing still has potential.
Right, just about how these things, that people use the term phasing in terms of the superposition. And then the Canadian at the same time. GDPS.
Whoa, that's different.
So the one that will cruise the bigger storm, I think, is ECWF.
Yeah,
Let's go back to that and stuff.
more in the future.
Right, in the future,
The
right.
thing I don't envy about that ECMWF solution too is even though it's slower, it's a much higher impact scenario in terms of the severe weather potential in the southeast.
Right.
I'll be flying home.
It's so foreign in terms of time scale that it doesn't fit into an individual forecast. So you kind of have to forecast 2 different events.
Right, so 2 scenarios, basically.
Realities, yeah.
Right. Let's go ahead.
I might fly through that upper front if this valley.
Coming out in Boulder?
Yeah, I'm coming home Thursday afternoon. That'll be awesome.
Unless there could be snow. Let's look at
You guys see
1
that?
to 6. Look at that. This one kind of gets,
That is a fantastic upper front.
and at the surface,
It's like one in Indiana.
Not bad. not that impressive, actually.
Yeah.
Right. Although, again, we should look at the accumulated snowfall for this.
We're just coming around the base of the upper trough. What about, I hate to keep doing this, what about the next day? No, still. It's divided allegiances. That's a pretty big snowstorm for Indiana if that turns out.
And go ahead, it's 180. I'm curious if there's going to be any interaction between, oh, look at this.
All right, here we go.
So the trough is, maybe captured up with what's at the surface. Yeah, I haven't looked at this scenario further out. Can we get lower than 981? Let's go every 6 hours.
Oh.
980, okay, we did 980.
That's even lower there, I bet. You
Yeah,
can see it.
can't do it, but it's all
You can
coming out.
probably go to a larger view.
Yeah, well, let's see if we can do that. Continental US, yeah, Continental.
Maybe not.
No,
Oh, we're limited to this. Anyway, so generally looks like a quiet weather pattern for us. Look at the total accumulated snowfall for these WF winter weather, please. Just to wrap it up, this will be it. Sorry to go long. Now, there's that band of snow here, and we could run the cursor over it. There's probably just a couple. 4 inches.
4 in the water.
Right, and then you go down to probably 6 or 7 inches in Indiana and eastern.
Yeah, that never happens in Champaign except this time.
Right. And then lastly, can we bring up weather and just look at the loss for the weekend?
Doesn't have a Kushner snow ratio for snowfall.
No, yeah, not for this, they have it for the other, for the GFS. So we bring up weather and new avian moss. We can look at just the moss numbers for this weekend.
48.
So tomorrow, 29, and then 48 for Sunday. And look, we don't even really drop much Saturday night into Sunday. And part of this, I think, because we have the wind, brisk winds. The MFI was forecasting perhaps, at least the relative humidities were going up in the boundary layer. Some cloudiness, and so it looks like this is forecasting overcast skies at this point. But the chances of precipitation are relatively low. And good chance that if it were to fall over the weekend, it would be more liquid. You can see that from the wet bulb temperature. Wet bulbs are probably around, 38, 39 or so at that point. And so warmer weather coming up. This is the moss guidance going a little bit further out, Sunday 48, and then we go into the 40s. Wow, we could go very warm every day this week.
Yeah. That'd be the first week that happened.
Right.
In months.
And Climo will be above Climo the early part of the week and then drop closer to it once we get to the end of it. So nice weather, if you want to believe this, choose to believe this forecast. Well, anyway, thank you, John, for a great briefing, and Pete as well for running the show for us and getting the graphics up.
Thanks, Pete.
And, next week, maybe you can just give a hint, Pete, because we can bring these maps in next time. Maybe working with the GFS model forecast, your second tab. Neat maps that Pete's been doing using some Python and some other data that we have available.
I'm recasting the stuff that we've had for years in Python, so the precip actually works right now. You don't get those freaky flashes that you always get, John.
Yeah, I love this.
So this is a 3-hour accumulated precip, sealable pressure in light blue and 1,500 thickness in yellow. We also have the total accumulated precip, so you can watch the storms go by and drop the precip down.
I think there's a future to this Python.
What else?
And you have the turbo maps too.
These turbopods, this is 500 millibar heights in vorticity, relative vorticity, not absolute. You'll note too, the isobars on the surface are 4 millibars, not 2, so that's good. This is working now too, the relative humidity lifted index. So the gray shaded areas are where the lifted index is below 0, and then the bluer areas are more humid, the purpler areas are drier. That's an 850 to 500 millibar average, and then we've got tropopause, 2PV. These are ugly maps. I don't know why the potential vorticity values are so noisy in GFS.
It has to do with their like search algorithm.
How they, yeah, this is smooth. I'm smoothing these, and they're still missing.
Also, it's interesting that the cutoff, I was thinking it emerged from that structure that was out in the western part of the United States, but it's not really that. It comes from something in the Northwest, yeah.
It's just like November 2019. exactly the same thing. Interesting.
So I'll put these up as a new version of the GFS, and I'm looking at doing some northern hemispheric maps as well, some close-up for the border degrees, so closer to Midwest.
Thanks, Pete, for putting these together.
Yeah, really good.
Tropopause pressure. I changed it so it's in hectopascals now instead of pascals.
Okay.
Anyways.
Well, look at this TPV. I think that's what it is.
Yeah, that for sure, yeah.
Line.
Will it survive the sunrise? Only if it gets exported to lower latitude, otherwise it's dead. Yep, sad.
Warm it up.
Okay, thank you all. Have a good weekend.
All right, thanks. All right, see each other in 2 weeks. Have a good lunch.
You're a lunch person?
Meteorology?
Right.
Yeah. Yeah. So I gotta be back.
Yes.
Yeah. You have to
You
go. See if you
You're welcome.
John?